Hi, pre-Cal honors. So we're doing notes today as first day of 6.3 on the bottom of page 13. Our objectives are to be able to graph parametric equations with and without a calculator, be able to eliminate the parameter, and describe a relation parametrically. So parametric equations, we need two equations to describe one relation, where typically y is in terms of x, but now with a parametric equation, x and y are both in terms of t. So we're going to start by making a table. So our interval is from -2 to 1. So we're picking values of t that are between -2 and 1. And now we're going to find x. So x is t plus 1. So if t is -2, x is -1. If t is -1, x is 0. If t is 0, x is 1. And if t is 1, x is 2. Okay, so now if y is t squared plus t, we could say -2 squared, or -2 is 2. -1 squared plus -1 is 0. 0 squared plus 0 is 0. And 1 squared plus 1 is 2. So if we want to sketch a graph, now we're going to sketch a graph with x's and y's. So we're actually not even going to look at the t. So we have a point at -1, 2, 0, 0, 1, 0, and 2, 2. Now don't forget though, they said that t was between -2 and 1. And this point right here, that was when t was -1. And this point was when t equals 0. So I'm wondering what happens between those two values. So why don't we pick another value for t? How about -1/2? So then x is 1/2 and y is t squared plus t. So we get a -1/4. So now it kind of helps to see, oh, this is actually a parabola, which is what I was expecting when I saw the t squared. So we're going to eliminate the parameter. So of the two equations, pick to get the t by itself. That would certainly be the x equation. And then take your other equation, and everywhere you see a t, replace it with x minus 1. So now we just eliminated the parameter because we have y in terms of x. And actually, this graph makes more sense because isn't this just a parabola with zeros at x equals 0 and x equals 1, right? Now remember, you cannot put arrows because the t interval was from -2 to 1, so you can't put arrows there. All right, we're going to turn the page, and now we're going to talk about parametrics, but we're going to use a calculator. So I have your graphing calculator handy. So we are going to graph x equals cos t, y equals sine t from 0 to 2 pi, and we're going to use our graphing calculator. And then later we're going to say, what would you do to the equations to make your graph move up, down, right, or left? I might even actually, have you try and change your window. So let's go ahead and grab our calculator. There we go. Okay. So what I'm going to do is I'm going to start by changing the mode. So if you go to mode right now, your calculator is probably in function mode. I would like it to be in parametrics. So notice I went down to parametrics and made sure that parametrics was highlighted. I hit enter on parametrics. And since we have cosines and sines, mode matters. So let's all be in radian mode. So now when you go to y equals, notice it looks a little different. It looks a little different because you have x and y, right? They're going to be in terms of t. Also, notice that if you hit this xt hamburger end button, you used to get an x, now we're going to get a t. Okay, so let's go ahead and type in cos t. And in y1, we will type in sine t. Okay, now if you go to window, I want to go from 0 to 2 pi. Oh, look, it's already in 0 to pi. So notice I have my t-step at 0.1. Let's just leave it like that for right now. I'll explain why in a little bit. So if you go maybe -4 to 4 and hit graph, watch what happens. So this is actually supposed to be a circle. Remember we talked about in the unit circle, and cosine was the x and sine was the y, but it looks more like a football. It's actually because the screen is rectangular. So if I know it's a circle, but if that bothers you, you can go to zoom square, and your calculator will square up your window. So now it looks a little bit more accurate. That's supposed to be a circle. Okay, so if we go to window right now, and if you change your t-step to something other than 0.1, how about 2? When I look at the graph, it doesn't look like it's supposed to anymore. See how it's very rough, a rough sketch? Because from 0 to 6.28, you asked it to make 2 calculations, and then it connected them. So that's not very accurate. However, if you make your t-step too small, like maybe 0.001, there you go. So now when you hit graph, notice that it's so small, it's making so many calculations. We're going to be here forever waiting for it to graph this circle. It'll be accurate, but it will take for a long time. So I'm going to hit on to make it stop. And that's why from 0 to 6.28, 0.1 was a pretty good number. Okay, so another thing we might want to talk about, what would happen when you go to y equals if you add 1 to the x? So for example, let's say I put +1. Now we're so well trained, you're probably thinking left 1, but watch what happens. It actually goes right 1, because what you see is what you get. You add 1 to the x, it'll move right 1. And for example, if I decided for the sign to do -2, it's actually going to move the whole circle down 2. Let's say you wanted to change the radius. You could do a vertical stretch or shrink. So I'll insert a 2 here. I'll insert a 2 here. It might be easier to see if I am not going down 2 and right 1 anymore, so maybe I'll delete that part. There we go. Okay, so if you look at the graph, notice that now it's a horizontal stretch and a vertical stretch, so it changed the radius. Okay, so what about if I wanted to just see part of the circle? If you go back to window, and let's say I wanted to go instead of 0 to 2 pi, let's say I just went from 0 to pi, notice that it would just graph 0 to pi, the top half of the circle. What if I went back to window and I decided instead of going 0 to 2 pi, I'd make calculations maybe -pi/2. Oops, try that again. There we go. Insert my negative sign. There we go. To positive pi/2. I'm going to take a graph, look at the graph now. Notice it's just the right half of the circle. Okay, so we're going to stop with the calculator for a little bit. We're going to do one more example. What about number 3? If I wanted to make a parametrization of the line segment, first of all, why don't we just start writing a regular equation? If I wanted the slope, I get -7/3. If I use this point, right? So now I could change that to a parametric equation if I decided to let the x be a t and just call xt. So I now described it parametrically. The only thing is I need an interval for t. I want it to be a segment where x starts at -1 and ends at 2. Since x is equal to t, I could say make that from negative to 2. That would work.